Hi all, welcome to the session. Today we are going to see how to solve a system of linear equations. How to solve the system of linear equations, let's consider a system of linear equation as x1 plus x2 minus x3 equal to minus 2, 2x1 minus x2 plus x3 equal to 5, minus x1 plus 2x2 plus 2x3 is equal to 1. Let us represent this set of linear equation in the form of matrix like this. In this, the first part represents the coefficients. This first one, this is the coefficient matrix corresponding to A. We represent it as A, and the second matrix is the variable matrix. We represent it as X, and the right hand side is represented as B. Okay, so we write this system of linear equations in the form of Ax equal to B, where A represents the coefficient matrix and X represents the matrix of variables. So here the variables are x1, x2 and x3. We write it in the form of vectors. And on the right hand side we have minus 2, 5 and 1. Okay. Consider this coefficient matrix A. For the first equation, the coefficients are 1, coefficient of x1 is 1, coefficient of x2 is 1, and coefficient of x3 is minus 1. So that is being written here in the first row, 1, 1, minus 1. And similarly for the other two equations. Okay, so this is the matrix form of or matrix representation of a system of linear equation, and using this matrix notation we can solve the system of linear equations. And to solve it we use the Gaussian elimination method. And coming to Gaussian elimination method, we have written our equation like this: Ax equal to B. Okay, this matrix represents A and this matrix and this is B. Okay, and how do we do the Gaussian elimination? And for that we have three steps. The first step is to write the augmented matrix. Second step is to convert this augmented matrix into row echelon form, and the third one is to find the solution. And let's check them one by one. And how to write the augmented matrix. Okay, it is written like this. This is our Ax equal to B, and this A is written over here, and the right hand side part is written over here, minus 2 by 5, and it is separated with a straight line, a vertical line. And this is our augmented matrix. So this is augmented matrix, and we have to convert this augmented matrix into row echelon form. So this is A, elements of A, and this is elements of B. Okay, coefficient matrix and the right hand side. And what is row echelon form? Row echelon form is like this. When we consider a matrix like this, I can say this is in row echelon form because when we take every row, every non-zero leading element should be a 1. Okay, all the non-zero leading element should be a 1. So when you consider this, the first element itself is 1, and when you take the next row, first element is 0 and the next non-zero element is 1. So that's fine. Then we take the third row, the first two elements are 0 and the first non-zero element is 1. And we are not bothered about the other elements here. Okay, so these elements are not considered here. And that can be any value. This X can be any value. Okay, then okay. Now other thing is when you consider this non-zero leading element, this 1, and all the elements below that element, that 1 should be 0. All the elements below this 1 should be 0. We call it as a pivot element, pivot. Okay, this is called as a pivot element. And when you consider this row, again, the elements below this 1 is 0. And here there is no more columns, rows here, so it is also fine. That is row echelon form. So we have to convert our augmented matrix into this row echelon form. Okay. Then to convert our augmented matrix into row echelon form, we have to follow some operations. It includes exchange of two rows, multiply a row with a scalar, and add two rows. These are the three operations we can apply on our augmented matrix to convert it into row echelon form. Okay. So how do we convert? Let's take this example. This is our augmented matrix, and this is row 1. We represent it like this. This is row 2, and this is row 3. And fortunately, the first element itself is 1. So what is the next step? We have to convert the remaining two elements in the same column to 0. Okay. Then how can I make it into 0? I can multiply this first row with 2 and subtract it from R2. Okay. So I can write it like this, minus 2R1. That means this R2, this row 2 has to be subtracted with 2R1. Okay. Then another thing is we have to remove the minus 1, negative 1 from row 3. So how to do? We can simply add with R1. Okay. And make sure that we are not making any change to R1. Okay. When we do these operations, it will not make any change to R1. We are changing R2 and R3. So what will be the answer after this? It is 1, 1, minus 1 and minus 2, and this will be 0, and this is minus 3, and this is minus 2, this is 3, nine, and now apply. The first row is over. Now we have to take this element. The first element is 0 in this case, and we have to convert this minus 3 into 1. Okay, what we have to do is we have to divide it with 3, or we can say that we multiply it with the minus 1 by 3. Okay, this gives 1, 1, minus 1, minus 2, 0, 1, 1, minus 1, minus 3, 0, 3, 1, minus 1. Okay. Then we have to make this value, this 3 as 0. So how do we do that? Minus 3R2. Okay, apply minus 3R2. So the answer will be 1, minus 1, sorry. It is plus 1, minus 1, minus 2, 0, 1, minus 1, minus 3, 0, 0, 4, 8. So it comes like this. And then now we have to go to the third row where we have to make this 4 as 1. What to do? We can multiply it with 1 by 4. So the answer is 1, 1 minus 1 minus 2, 0, 1 minus 1 minus 3, 0, 0, 1, 2. Like this. Okay. So now this matrix is in raw echelon form, where this first row corresponds to x1, this corresponds to x2, and this corresponds to x3. And we have to find out the solution. So let me take this. Okay. So this is the raw echelon form of our matrix, of our augmented matrix. Now we have to find out the solution. So this statement says that, x3 is equal to 2. Okay, this statement, this is equivalent to, this column is equivalent to x3. So this says that x3 is equal to 2. And the second row says that we have x2 minus x3 is equal to minus 3. And when we substitute the value of x3 over here, we get 2, which is equal to x2 equal to minus 1. Okay. Now, we take the first equation. First equation is like this. x1 plus x2 minus x3 is equal to minus 2. And substitute the values of x2 and x3. x2 is minus 1 and x3 is 2. Minus 1 minus 2 is minus 3. So it will be x1 equal to 1. Okay. So we got the solution like this. x1, x2, x3 is, x1 is 1, x2 is minus 1, and x3 is 2. So that is the solution for this system of linear equations. And we have to consider two more things over here. One is when we convert it into row echelon form, we can find out base variables and free variables. Base variable means when you take a matrix like this, okay, when you got the raw echelon form of our augmented matrix, and all the columns or all the variables having pivot elements are called base variables. Okay, when you consider x1, it has a pivot element. When you consider x2, it has also a pivot element. And for x3, we have a pivot element. And when you come to x4, there is no pivot element in this column. So we can say that x1, x2, and x3 are base variables because they have pivot columns. Then x4 is a free variable because it has no pivot element. Okay, these two concepts are useful when we solve the equations which has infinitely many solutions. So that's all about the solution of system of linear equations. We have taken very simple example which has a unique solution. And in the next session, we will see the set of linear equations which have infinitely many solutions. Thank you.